Hello everyone, welcome back to lesson number 15 for Calculus AB, where we're talking about how to integrate basic polynomial functions. And this is our last video where I'm going to talk about how to take a antiderivative of a f prime of x and actually figure out what our c is. So for the last two videos we've been doing plus c plus plus c plus c. So what we're going to do here is we're trying to find f of x, and we're given the f prime of x function. So this is the first time where I can actually show you guys that f of x is always going to be equal to the antiderivative of f prime of x dx. So you guys know if I wrote out f of x is equal to f prime of x, that this is the derivative of this. You've learned that. That's a notation. Well, if I want to go from the derivative back to the function, then I simply have to integrate this derivative. And that's exactly what we do. So if I want to find what f of x is, then I need to plug in my function. My function f prime of x is just going to be 3x minus 1. And again, ladies and gentlemen, you cannot forget the dx. You cannot forget the dx. It's not in the problem. It's here. I always tell students that when you're taking assessments, when you're looking things over, make sure to look at other previous questions. So like at the very top of our page here, it's asking us to solve this problem. This is a practice question you guys can do. And then you can say, oh wait, there's the dx. I cannot forget the dx. Every integration you're going to see is going to have a dx on it. All right, so let's integrate this like we normally would. And from our previous videos, using the power rule, we're going to take 3 and we're going to do x, and then we're going to go to the second power, right? We're going to add 1 to our exponent, and again, whatever this is, we're going to divide by that number. And then the antiderivative of any constant is just that constant x plus c. Now this is what we've learned thus far. This is what we know. However, we're given that f of 2 equals 3. So I know that when I plug in, I'm just going to write it right here. So I know that when I plug in 2, everywhere I see an x. So I'm going to get a 2 squared over 2 minus 1 times 2 plus c. I know that that's going to give me 3. That's going to give me 3. And all I have to do now is find what c is. And that tells me what it is. So this initial condition, that's what we call this. This initial condition basically tells us what we can do to find this problem. So I know that this is going to be 3 times 4, right? 3 times 4 is 12. 12 divided by 2 is 6. So 6 minus 2 plus c is equal to 3. So I get 4 plus c is equal to 3. So c is going to be equal to negative 1. C is going to be equal to negative 1. So our final answer is we're going to take this out. We're going to go ahead and rewrite this again. So f of x is going to be equal to 3 halves x squared minus x minus 1. So now we're able to find our c value based on the fact that we were given an initial condition. And that's exactly what you guys would do over here at example number 4. Okay? So let's look at this example question 5, and then we're going to do question 7, and we'll be done. Now notice this one, I've given you guys a second derivative, and then I've given you an initial condition for the first derivative. I've also given you an initial condition for f of x. And we want to find f of x. So just like in the previous example, if I want to find the first derivative, I can just integrate the second derivative. dx, right? dx. I can integrate the second derivative. And you can do that for everything. If I want the 17th derivative, then I'm just going to integrate the 18th derivative. You never have to do something like that, but that's the general point, is that this kind of undoes the first derivative, or the second derivative. So the first derivative is going to be equal to the integration of just whatever our function is. We chose something very easy, just 2. And so this, again, first derivative is just going to be 2x plus c. Right? And that, again, is going to be equal to our first derivative. So all we have to now know is that f prime of 4 equals 1. So f prime of 4, I'm going to plug in 4 everywhere I see an x. I get 2 times 4 plus c. That value is going to give me 1. So I'm going to get 8 plus c is equal to 1. And I'm going to get that c is equal to negative 7. So I can now say in this problem that f of x, and I'll put it over here. So f prime of x is going to be equal to 2x minus 7. 2x minus 7. And so it does not surprise us, ladies and gentlemen, that if I want to find f of x, I need to integrate this dx, right? So f of x is going to be the integration of our first derivative, as we mentioned in the question number 3, or the first example that we did in this video. So let's integrate it. So f of x can be equal to, I like this one 2x because it's 2x squared over 2. So this is a really nice one just to know off top of your head that the integration of 2x is just going to be x squared minus 7x plus c. And so just like in the previous part right here, I'm given an initial condition. I'm doing this problem right here, so I should not look at that up there. I'm doing this, so I know when x is -1. So f of -1, excuse me. So I'll go ahead and do -1 squared, right? Because these just cancel out. So -1 squared minus 7 -1 plus c. That's going to give me the answer of 2. That's going to be the answer of 2. So I'm going to have 1 plus 7 plus c equals 2. Now we're doing simple math. We're going to get 2 minus 8 is going to be -6. And then when all is said and done, ladies and gentlemen, our answer is what we see right here. F of x is going to be equal to 2x squared. Sorry, x squared, not 2x squared. I need to cancel that out. It's going to be equal to x squared minus 7x minus 6. And so you could, if you wanted to, go back and verify that if I put in -1 right here, would I get 2 out? Then you can take the derivative and get 2x minus 7. If you plug in 4, well, you get +1. And then you can take the third derivative, or second derivative, which again would just be 2. And you would see that you would have the right answer for all of these. Okay? So a little bit more work, and we would have to give you the actual initial condition to do these problems. All right, so let's look at our last example for the lesson, and the rest of it just practice, practice, practice. It says, given that the graph of fx passes through the point 1, 6. So I stopped right there, ladies and gentlemen. I said 1, 6. If it passes through the point 1, 6, that is a solution to our function, our graph. So I can call this an initial condition or just a condition that satisfies this curve, right? And the slope of the tangent line, at any point is 2x plus 1. When you guys learned that the slope of the tangent line is the derivative, which is the rate of change of our function. So we now know, based on our wording up here, that f prime of x is equal to 2x plus 1. So now we're back to what we just did in the very first video, or sorry, the very first question in this video, is I want to find out what f of 6 is. Well, in order to find out what f of 6 is, I got to first of all figure out what f of x is. So all I have to do is integrate my f prime of x. So again, I'm going to write this up just for us so we can have as our guide. So we're going to integrate this. So f of x is going to be equal to the integration of 2x plus 1, again, dx. You're going to hear me say that, 2x, 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 or dx, dx, dx. And so f of x, and again, guys, look at how I'm doing the problem. And notice that I'm keeping the integrity of the problem alive. I don't drop the integration. I don't drop the dx. I keep everything fluid. And please make sure that you guys do that when you're doing your problem set. Again, I'm going to go ahead and just say now that we all know that the integration of 2x is x squared. And then it's going to be, the integration of 1 is just going to be x. And we're going to do a plus c, right? Plus c. And the more you practice, the better you're going to become at this. And we now know that f of 1, which is going to be 1 plus c, is going to be equal to 6. So I'm going to get 2 plus c is equal to 6. So c is going to be equal to 4. C is going to be equal to 4. So we'll finish this problem up. We're going to get f of x. It's going to be equal to x squared plus x plus 4. Now, I've run ahead and put it here in purple that, guys, make sure that we understand what the question's asking us. The question's asking us not what is f of x, which is what you see right here, and that's great, but it's actually asking us what's f of 6. So all we have to do is just plug in 6, right? So we get 36, we get plus 6, we get plus 4. So this is really 10, right? So 36 plus 10 is 46. So the answer to this question would be 46. All right, guys, I hope that was helpful for you. I've now finished this lesson. And the next page, if you guys want to, it is just practice, 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 practice. And there you guys go. So I will see you guys in the next video for the next lesson.